Okay, so welcome back to the lesson on absolute value inequalities, part 2. And so by now what you should have done is made an attempt at completing examples 1, C, D, and E independently or in collaboration with those sitting around you. And so now we're going to go through and just go over the solutions. Okay, so absolute value inequality. We have a less than, but before we are able to convert the absolute value inequality into a compound inequality statement, what we need to do is isolate our absolute value. And so what I'm going to do is, sorry, minor error, I'm going to subtract 3 from both sides, and that's going to result in the absolute value of x minus 5 less than or equal to, and when I subtract 3 from both sides I end up with minus 2. Now, as is usually the case, I always put in an example which tests your full understanding. In this case, if you read this statement, it reads the distance of this number from 0 is less than or equal to minus 2 units. And so this creates an issue for us because absolute value, which is representing distance, cannot be a negative. That does not mean x cannot be negative. X is allowed to be negative, but you cannot have a negative distance, which is what this represents. And so this is a relatively quick example because the answer is empty set or no solution. It is not possible to solve this absolute value inequality. Okay, so we'll move to D, which is very similar. Once again, I'm going to start by isolating my absolute value expression, absolute value of x minus 5 less than or equal to, and this time we do have, you notice the similarity between the two examples. This time we do have a workable absolute value inequality, and so we're just going to go ahead and solve that now. So absolute value of x minus 5 less than or equal to 4. What this translates to is that the distance of this number is no more than 4 units from 0. We can't graph it yet, but what we are able to do is convert this now into a compound inequality expression. And so it is going to be between 4 and minus 4, because if it is no more than 4 units away from 0, then the value of the expression x minus 5 must be between minus 4 and 4. And so I drop the absolute value signs and rewrite it as a compound inequality. In this case it's an AND compound inequality, and now I'm in a position to solve. And so I'm going to isolate x by adding 5 to all sides, in this case, resulting in 1 less than or equal to x less than or equal to 9, which I am then able to graph on my number line. And so solid dot on 9, solid dot on 1, and we are going to join those. Okay. And for the final example, or the final example you needed to try, what we have here is our greater than absolute value, and this is more complicated because we also have a coefficient in front. As mentioned several times, you do not distribute the 3 in, and we do not drop the absolute value unless and until we have isolated it and rewritten it as a compound inequality. So what we're going to do is start off much like we did before by isolating the absolute value expression. And so if I add 4 to both sides, 3 times the absolute value of 2x minus 1 is going to be greater than 6. I then need to divide both sides by 3 so that I have now isolated my absolute value expression, and only at this stage can I convert that into a compound inequality statement. So I'm just going to rewrite that on the right hand side. the expression is more than 2 units away from 0, and so that means the expression, which in this case is 2x minus 1, is going to be greater than 2, or if you are further away from 0 than 2 units, you could also be to the left of minus 2, and so we also have 2x minus 1 less than minus 2. Notice we have not flipped the sign because we've divided by a negative. That is not what we've done. What we've done is converted this to a compound inequality, and since we have to be further away from 0 than 2 units, we can move to the left as well, which is why we have less than minus 2. This is the most complicated part. If you can understand this part, then you can be confident that you have a good conceptual understanding. What we'll do now is go ahead and solve each of these individually and then graph our solution. Okay, so adding 1 to both sides, I have 2x greater than 3, and dividing both sides by 2. Part of my solution is x greater than 3 over 2 or 1.5. Either way, you can leave it as a fraction if you prefer. Solving the other branch of the inequality, 2x less than minus 1, and once again dividing both sides by 2, x less than minus 1 over 2, and we are now going to go ahead and graph those, and so that's 1.5, open dot on 1.5 and arrow going to the right hand side, open dot on 1/2 and arrow going to the left hand side. Excuse the arrow, not very neat. Okay, and that is the solution. Okay, let's move on, and for the last example I'll just go through this for you. And so what we have here is a reminder of absolute deviation, which is the absolute value of the difference of x and a number, and this time applied to inequalities. And so here we have, this is example number 26 from page 401 of your book. The absolute deviation of 2x from minus 7 is greater than or equal to 15, and so is greater than or equal to 15 is explained over here. Absolute deviation is the absolute value of the difference between 2x and minus 7, and so here we have our expression. Okay, and so I'm just going to clean the expression up a little bit inside the absolute value. That simplifies as 2x plus 7. I have once again a greater than absolute value, so this expression is more than 15 units from 0, and so I'm now going to drop the absolute value and write my compound inequality, and so 2x plus 7 is going to be greater than or equal to 15, or 2x plus 7 is going to be less than or equal to minus 15, more than 15 units away from 0 on the left hand side of the number line. And again we'll just go ahead and solve. I'm moving the 7 to the left hand side and dividing both sides by 2. X greater than or equal to 4. Over here we have 2x less than or equal to, I'm subtracting 7 from both sides, and so that's going to give me minus 22 on the right. Divide both sides by 2, and what we're going to have now is x less than or equal to minus 11, and as mentioned before, this is an OR problem. No number line provided, but we'll just sketch ourselves a very rough number line. There is 0, we have minus 11 approximately here, closed dot and going to the left, 4 approximately here, closed dot again, and number going to the right hand side. Okay, what you need to do at this point, after you've copied down model solutions for all of the examples that we've worked through together and made corrections if you need to on the previous examples, is to begin work on your assignment. Remember, for each of the problems that you do, you must check the solutions at the back of the book. Please make sure you're also asking the substitute if you have any questions.